And here we go, we're in Wireshark. I mean, how cool is this? One thing that I will tell you, a little tip here. If you notice, I've got this up and it shows I've captured 14 packets. Well, I know that I've captured far more than 14 packets. One thing you're going to want to do, at least what I've run into with this version of Wireshark using it with GNS3, is go up here and just hit this refresh. It's going to actually reload the capture file. Booyah, now you've got 321 packets. And I'm not going to go into how to use Wireshark, but what we're going to do here is we're actually going to filter. What we want is we want a specific type of message. And LDP, we just want the LDP messages. And if we look, we should see, I mean, it's sending out keep alives all the damn time, these hellos and keep alives. This is what we're looking for, this mess here. This is the point where we cleared the LDP neighbors, and this packet is actually the one we're looking for. It's sourced from 4.4.4.4, which is the loopback IP address on R4, and that's what LDP is using for basically the equivalent of a router ID. It's going to 3.3.3.3. And so that's the packet that we want to look at here. And I think if I just double click that, I can just get to the packet. All right, so we're looking at this guy, and what we want to do, you have to drill down a little bit here. So go to Label Distribution Protocol, and what this is all of the prefixes that R4 is advertising to R3. So each of these label mapping messages is a prefix. So we want to find, and unfortunately, finding 4.4.4 here is, we'll just take the fourth one. See if that's, so you got to do a little drilling down. So you got to pick the right mapping message, and then we want to go to the forward equivalence classes, and then the FEC, which is forwarding equivalence class elements, element 1, and that's, you can see this one is for prefix 3.3.3.3. So let's, isn't this exciting television? Or, well, not television, obviously. This is fucker all. All right, let me pause real quick, and I'll find the. Actually, I don't know how to pause. Son of a bitch. Well, we're gonna do this live and possibly edit this. There we go. Okay, so it was the third one down. That's the only pain in the ass here. So now you can see this is a prefix. This is its length. It's IPv4. Blah, blah, blah. What's cool here is if we go to the general label TLV, generic label 3. And if you remember from earlier, the label 3 is a reserved label in MPLS, which is actually the implicit null. So all of that was just a fancy way of showing you that there is actually a label that's advertised when you have an implicit null, and it is label 3. Okay, let's go ahead and wrap this up then. So that's the basics for Pentultimate Hop Popping. Let's go ahead and just quickly review before we end the video here. And like I said, the main reason for PHP is that it saves that additional lookup on the last hop router. It uses implicit null to signal its upstream neighbors to go ahead and pop for that the tag for that prefix, rather than swapping a tag and sending it on to the last hop, which would result in 2 lookups rather than the 1. It uses the implicit null to do that, and as we saw in Wireshark, the implicit null is actually an MPLS label with a value of 3, which is one of the reserved values. Again, reserved values are 0 through 15, and Pentultimate means next to last. So basically the Pentultimate I got through most of this without fucking tripping over my tongue too very much, so it's just fitting I would get to the end of this and completely bone that up. The Pentultimate router pops the label for any packets from which it has received an implicit null for that prefix. Well, again, I should probably have not put that in the slide because that's just kind of gibberish. What you really want to know is that the implicit null is advertised by the last hop router in a label switch path for all connected and summarized prefixes in its routing table. And I think that's it. Thanks for watching, and see you again soon.